My name is Mabu, and then I represent these guys, this team, Data Wizards we are. We are about teaching machines, just like the picture demonstrates there, using sort of lots of data. So my team is made of me, Ofenzwe, Doctor, and then there is a missing guy, Aside Lava. We're mostly data scientists and machine learning enthusiasts and researchers. So we chose to solve this problem, and the way we wanted to solve the problem was to pose a question: can we build a robust machine learning classifier that can reliably detect fraudulent transactions in real time? So basically that's the question. And the answer was that we think we can, because other people are doing it, so obviously we can do it. So we built Fraudmaster, which is a binary classifier based on a combination of machine learning algorithms using adaptive learning. So, yeah. So the approach here is that we use scikit-learn, which is a library for machine learning in Python, to do something called model selection, where we take a lot of models together and we ensemble them, and then we combine them, and then we take the best one out of that. And then we use a lot of different variations. So that's random forests, logistic regression, decision tree classifiers. We took the best one in the industry, and then we select the best, and then we apply real-time adaptive modeling to it. And with a little help from humans, the machines can get better at recognizing what is fraudulent and what isn't. So obviously, when you talk about these kind of things in machine learning, the immediate problem becomes the data. And because we are blessed with platforms like Kaggle, where you can find data from all sorts of environments, and it's important because it's production data. I mean, production environment data, so you can simulate the real world with it. So we obtained this credit card fraud data, and then in the data you have about 284,807 entries. So that's rows of data, and you have 30 features. The 31st feature is the class, which we don't count. And we took 70% of the whole data and then set it aside for training. For evaluation, we took 20% of the remaining 20%, and test, we took the 10% of it. So evaluation is when we adapt our model and continuously improve it, and test is when we apply unseen data completely. And did we get luck? So I wish I presented a better diagram, but so this is what you're looking at here. It is the accuracies of the models that we assemble. So LR there is logistic regression, so that's 0.99, so that's 99.75%, and accuracy. And LDA, linear discriminative, and then we have KNN, K nearest neighbors, we have decision trees there, and then we have naive bias. So all of them, as you can see, have fairly high levels of accuracy. And this for us is a plus. So the architecture is a bit ugly, but it's complicated, so we couldn't find a way to depict it in a way that anybody can understand. But the idea here is that the adaptive modeling that we use is that the fraud engine in the center continuously changes its decision-making ability based on what the modeling server is sending to it, what the mobile app that is developed is saying, and then what the dashboard is saying. So in the dashboard, you'd find human experts who can correct the machine. And then on the mobile app, you have users who can also correct the machine. And then on the modeling server, you have a continuously being trained model that can also update the fraud engine. And the incoming transactions there come from data in real time. The ultimate goal, what we want to do is sort of have a one-stop fraud intelligence platform using some kind of crowdsourced training data. So can we sort of pull the data from everywhere we can, transactional, or even maybe tap into the blockchain data that we already have, and find a way to retrain this. And use context-dependent authentication, so based on a trust model of the user, like your location, your device that you use, and the stuff, can we ultimately not authenticate you based on the fact that we have a model? So this is where it ends, and we have to demo it, which is quite challenging. So that is the dashboard where you land. Can you refresh it? So that is the dashboard. That is the transaction center, and then all these transactions here are the transactions that our model have thought that they were fraudulent. And then what a human administrator can do is that they can now either release the transaction that's been blocked by telling the machine that this is not a fraudulent transaction. And when that happens, then back to the diagram, the machine immediately re-adapts and changes its decision based on that. And then, yeah, well, that's just a question there. You can just say no and move on. And then you have locked transactions there. You can open a transaction, you can lock it, and then when a transaction is locked, the human expert can come here and actually correct the machine continuously. But obviously this is just because we're demonstrating. You don't want this human expert to be here. Actually you can have another layer of machine learning that changes the model itself, not a human. But it's a hackathon, so you can't do everything. So that's it. You can click on the demo there. So this is the transaction center. So you can click on the demo, those two settings.
Time up, Q&A.
So can we go back to your infrastructure, please?
Maybe just tell them I have a minute left.
Yeah.
Yeah.
Oh.
So we